we were previously working on a project with an automotive manufacturing company. So this is a tier one supplier to the global car manufacturing businesses, so to Ford and Toyota and so on. And on a fundamental level, we were developing nanocomposite metal alloys. So this is where we were depositing very thin alloy coatings that had particular crystal structures and combinations of crystal structures, so the way the atoms join together. And by tuning those structures, which we were controlling via the manufacturing process, we were able to generate a thin film, so only 40 nanometers thick, that had particular optical properties, corrosion resistant, abrasion resistant. It could handle temperature cycling and those kinds of tests. And that was the primary component as the reflective layer in the world's first plastic automotive mirror. So this is it's a plastic substrate that has a range of coatings on the front of it, where to date 3.5 million of these have been manufactured here in Adelaide by our industry partner SMR, and then exported to the US on the F-250 pickup truck for Ford. So in terms of a project that I can talk about that I'm most proud of, here's where we've done some underlying fundamental science, understanding really how the atomic structure of these materials play out in their properties, but then been able to turn that into performance parameters, go through the scale up, and actually help our industry partner now commercialize the technology. So it's that had all the ingredients in it. That was pretty exciting.
Yeah, that sounds really cool. You must be really proud that something you worked on the lab is now being used in the real world. I mean, that's the whole point, sort of, right?
Yes. And so that's why, on a technical level, that was really good. But we learn a lot of lessons about just the general way you can run the projects to maximize the chance of success. And so I spent a lot of time talking then with people about just the general process of how to get that science out into commercial products. Because at the end of the day, a lot of the nanotech and a lot of the material science we do is already geared at applications. So it's primed up, ready to get out of the lab. But it's not easy to do. As a lot of people know, it's not easy to do. So
it's not easy. The research is perfect, but then the product development part and bringing it to the production line, into the industry, that's a lot of work.
Yes. A lot of work, a lot of time, and a lot of money.
Yeah, absolutely. Yeah, you need a lot of patience and a lot of breathing in between, like, okay, it's gonna work.
We hope you enjoyed this snippet. Check out the full episode by following the link in the show notes. A lot of work goes into creating every episode of Under the Microscope. We meticulously look for the best materials and nanoscientists from around the world to feature on Under the Microscope. So do leave us a review and share your favorite episodes with your favorite people. Thank you very much.